right, almost there with rationals algebraics. Unit 10, we start graphing these lovely things. But to finish up Unit 9, we're going to look at solving rational equations. Now, solve a rational equation. First off, what is a rational equation? Well, it happens to be one in which one or more of the terms is a fractional one. When solving these rational equations, we use one of two methods that will eliminate the denominator of each of the terms. Now, we're going to look at the easy stuff first. If I have a fraction equals a fraction, well, think about what you did when you did proportions. We cross multiply. So here, if I've got 4 over x equals 9 over x minus 2, two fractional terms are equal to each other, I'm just going to cross multiply. So if I come all the way down here so we can take a look at this, if I have a over b equals c over d, I multiply AD, and that's equal to BC. So I'm going to use that same method here. 4 times x minus 2 is equal to 9 times x. Now I do have to distribute the 4. And then I simply solve for x. Now, the catch here is I do have to look at what the restrictions are on the variable. Notice x cannot equal 0 and x cannot equal 2. If x is 0 or x is 2, then one or more of the terms in the original equation are undefined. Therefore, when I solve for x, if x comes out to be either one of those values, then there is no solution. That is one catch that you do have to make. Now, the other way to do it is you can always plug it back in and check. Okay, so I plug the -8/5 in and I do my entire check. Division of fractions means you flip and multiply by the divisor. Simplify each side. Everybody good there? And again, the checking, just make sure you did the algebraic work correctly, as well as you didn't identify a restricted value as a solution. Now, this is a little more complicated, but you can do it. To solve a rational equation in this method, we identify the least common denominator, the LCD, and we multiply each side of the equation by the LCD, then simplify. Solve the resulting equation and check the answer. Now here I can multiply both sides by the LCD, not necessarily by a form of 1. Why? Because whatever I do to the left side, I do to the right side, and I maintain the balance. So, first things first. Before you even start solving, identify your restricted values. So here, my restricted value, x, does not equal 0. Okay? Now, let's go to the next one. And the LCD for 3x, 4, and x is 12x. So I'm going to multiply the entire equation through, both left and right side of the equals, by 12x. I do that, and notice I've got the things that cancel. I rewrite the equation, and I solve, and I get 4/5. I keep on going, and I check my answer, and it does check. 4/5, by the way, was not the restricted value, so I'm okay. I don't have to list my restricted value. I just have to make sure back here that x does not equal 0 when I get my final answer, that my final answer is not a restricted value. If it is, then I know it won't actually solve the problem. Now, the check is very important in rational equations, as you can get answers that do not check in the original equations because of restrictions. So, let's look at this example. 1 over a plus 1 over a minus 1 is equal to over a squared minus 1. First, find the LCD. Well, first thing I would do is I would factor this guy. A squared minus 1 is a difference of squares. Now, I'm going to multiply both sides by the LCD. Multiplying both sides by the LCD and canceling where I can cancel or simplifying. Leaves me with a minus 1 plus a plus 1 equals 2. 2a equals 2, a equals 1. Hooray! Now if I check, well, when substituted into the original equation, a equals 1 yields an undefined fraction. Whoa. Therefore, there's no solution. Now, did I have to go through the whole check? No. Up here, I could have said a does not equal negative 1 or 1. Negative 1 or 1. Then, when I solved and I saw that a equals 1, I could say, but 1 is restricted. Okay, but 1 is restricted, so no solution. So I could actually do it either way. I could do the check at the end, or I could figure out the restrictions in the beginning. Now, let's try some together. Or actually, how about if you try them? Go ahead and pause the video and then start it again to see how you did. Here, get rid of this guy. X equals 4. And there are no restrictions, so we're okay with it. And if we put it in, 4 plus 2 is 6, divided by 3 is 2. 2 times 4 is 8. Minus 4 is 4, divided by 2 is 2. We're good. Over here, again, you can simply cross multiply. You have a fraction equals a fraction. So cross multiplying works. And here, my restricted values, x does not equal negative 1, x does not equal 3. I don't have to worry about that, though. I got 11. Try these two. Now, these two are going to be a little bit harder. You can't just cross multiply. Okay? Do you have it? Let's see. Now remember, up here, my restricted values, a does not equal 0, a does not equal negative 1. I come all the way down and I find out that a is equal to negative 5. That'll work. Over here, x does not equal 0. I solve. X equals negative 6, x equals 1. Great! Both of those will check. And moving on, let's try these. These are a couple that you can do with cross multiply, or you don't have to. Notice, if I have the same denominator on both sides, I can just lose the denominator, right? I don't even have to cross multiply. Now, one thing to be careful about when you just do that is remember that I do have to say that, that x does not equal 3. Now, if I multiply both sides by the x minus 3, I essentially cancel those. Then I get x squared minus 1 is equal to 8. X squared equals 9. X is equal to plus or minus 3. But what did I find out? X might be equal to plus or minus 3, but x can't be 3. That's restricted, so only x equals negative 3 is a solution. You got to be very clear when you finish solving these on quizzes and tests. Over here, I can just multiply both sides by the 2x plus 3, which is the same thing as cross multiplying if you think about putting that over a 1. Okay? Now, this one gets a little complicated because 3x squared plus 2x minus 3 doesn't factor. Therefore, you have to use the quadratic formula. Now, the nice thing is with the quadratic formula, when I get my final answer, I can be pretty sure that up here where x does not equal negative 3/2, okay, that quadratic formula is not negative 3/2. So I'm good. All right, what about this one? Go ahead and pause the video and try it. Welcome back. Let's see how you did. Okay, first, you should recognize that c squared minus 4 is your common denominator. But you put it in the factored form when you're multiplying by these other two expressions so you can cancel. And remember, up here, by the way, c is not equal plus or minus 2. So I keep on going, and I get c is equal to negative 3. Hot dog. Now, if I put the negative 3 in, I can put negative 3 in, and I'll find out that negative 3 does, in fact, check. Here's another one. Remember, factor this guy, and he does factor. Oh, look at that. He factors to x minus 8, x minus 2. And everything can be pulled out. Except what's going to happen here? Oh, look, x squared and x squared. I'm not going to have a quadratic. I'm just going to have 4x equals 48 and x equals 12. It actually winds up not being as bad as it appeared at first. Don't forget that x cannot equal 8, x cannot equal 2. 12 is not 8 or 2, so you're good to roll. Ooh, a word problem. The sum of twice a positive integer and 4 times the reciprocal of the integer is 9. And find the integer. Well, first off, what in the world is the equation saying? Notice I put in red the words that are important. Sum of twice a positive integer and 4 times the reciprocal of the integer is 9. So the sum tells me I'm going to add two things together. Reciprocal tells me I've got to flip something over. So if I have the sum of twice a positive integer, 2x, plus 4 times the reciprocal, 1 over x, is 9. Write it out. Now, the one thing that I know here is x cannot equal 0. So now before I'm going to multiply everything through by x, and I've got a quadratic. Will the quadratic factor? Are there factors of positive 8 that add up to negative 9? You bet there are. Now I've got it factored. Once I've got it factored, I'm going to solve using the zero product rule. Now here's where you got to be careful. I get that x is equal to 1/2 or x is equal to 4. Now 1/2 is not a restricted value, and neither is 4. However, let's go back and look at this. The sum of twice a positive integer and 4 times the reciprocal. I need an integer. 1/2 is not an integer, therefore only 4 is my answer. The solution is the positive integer 4. Had the x equals 4, had that been a negative number, I wouldn't have any solutions that match what the word problem is asking for. So again, here, you're not only ruling out 0 because it's a restricted value, you're ruling out anything that's not an integer because it's not what was asked for in the word problem. In summary, identify your restricted values first. That way, when you're done solving, you know whether you've got an answer or not. Cross multiply and solve for the variable. That's method 1. That's when you have a fraction equals a fraction. Method 2 is multiply the entire equation by the denominator or denominators, basically the LCD, then solve for the variable. This may mean solving a quadratic. Always check the solution.